Hi ladies and gentlemen, I'm delighted to welcome you to today's presentation on volumetric analysis, specifically focusing on the precise determination of acetyl salicylic acid ASA in aspirin tablets. Before we dive into our presentation, I would like to take a moment to introduce the amazing team behind this project. First, we have IZZATI binti Muhammad ZAMRI. Next, we have ILHAM NAJAH binti Muhammad RAFEK. Then we have ALEA SYAMIERA binti Muhammad HISHAMUDDIN. Finally, we have NAWAL ATHIRAH binti Muhammad SYAZWAN.
Aspirin, also known as acetyl salicylic acid, is a common drug which is a common over-the-counter medication that belongs to a class of drugs called non-steroidal anti-inflammatory drugs. It can come in a variety of forms, including capsules, liquid, and tablets. Aspirin is widely used for analgesic, antipyretic, and anti-inflammatory properties. An analgesic is a type of medication that is used to relieve pain. They are used to moderate pain such as headache and muscle cramps. An antipyretic is a type of medication that is used to reduce fever. It is effective in reducing fever by acting on a part of the brain that regulates body temperature. Volumetric analysis is one of the quantitative analytical techniques used in chemistry to determine the concentration of a substance in solution. By using the volumetric analysis, we can determine the amount of ASA in aspirin. The key components of volumetric analysis include titrant, which is solution with non-concentration, the analyte, non-concentration, indicator, and the apparatus. By carefully measuring the volumes of the solution and understanding the stoichiometry of the reaction, the concentration of the analyte can be accurately determined. The list of apparatus that commonly used for titration is: the first one is pipette, which is used to transfer an accurate solution into the conical flask. The second one is volumetric flask. They are commonly used for diluting of the sample to certain volume. Next is burette, used for delivery of an accurate amount of the solution. The conical flask is used to mix solution in titration. The glass funnel is used to transfer liquids into containers with small openings such as burette. The last one is dropper. Dropper is used for transfer small amount of solution up to the calibration mark of the volumetric flask.
Theory for the volumetric analysis involves titration, where a solution of non-concentration, which is titrant, react with a solution of the analyte ASA in aspirin to determine its concentration. In this case, an acid-base titration is used, where the ASA is titrated with a strong acid such as hydrochloric acid HCl. Continue with the components of titration. The first one is endpoint, when the solution from the colorless solution turns into the faint pink color. And then the second one is the indicator that we use in this process, which is phenolphthalein. And then the third one is analyte. We use acetyl salicylic acid ASA combined with the sodium hydroxide NaOH. And then the last one is titrant, which is hydrochloric acid HCl. The chemical equation for this process is CH3COO C6H4 plus with 2NaOH. 2NaOH is the excess amount. And then we'll produce CH3COO Na plus with HOC6 H4COO Na+. This is the first equation for this process. And then for the second one is NaOH plus with the HCl, and then we'll produce NaCl plus H2O. And the NaOH is the unreacted. We're gonna start the process with hydrolysis of aspirin. First, we're gonna weigh 3.8542 gram of aspirin tablet using a weighing paper, and then we're gonna transfer it into a 250 ml of conical flask. After the transfer, we're gonna add 25 ml of 1 molar NaOH solution using a pipette, and also 20 ml of water to the tablet. After adding all the solution, we're gonna heat it using a hot plate until it boils for 10 minutes and then cool it in the room temperature. And finally, finally, after the solution is already cool, we're gonna transfer the aspirin solution into the 250 ml of volumetric flask, and then we're gonna dilute it until the calibration mark and carefully using the dropper when the level is near to close. Start with the back titration process. Pipette 25 ml of aspirin solution into a 250 ml of conical flask, and then add 2 or 3 drops of the indicator phenolphthalein to the solution. Slowly titrate 0.1 molar HCl solution to the aspirin solution while continuously swirling the conical flask. Stop when the indicator changes color from colorless to faint color pink.
Now we move to the result of the experiment. In this table, we have a rough titration and accurate titration in order to get a concordant result. This shows a series of calculations used to determine the mass and percentage by weight of acetyl salicylic acid ASA in a sample. The first step is calculate the initial moles of sodium hydroxide. The initial moles of sodium hydroxide are calculated by multiplying the concentration of sodium hydroxide, which is 1.0 millimole per ml, by the volume of sodium hydroxide used, 25 ml, resulting in 25 millimole of sodium hydroxide. Second step is calculate the moles of sodium hydroxide unreacted. The moles of sodium hydroxide unreacted are calculated by multiplying the concentration of hydrochloric acid, which is 0.1 millimole per ml, by the volume of hydrochloric acid used, 18.55 ml, resulting in 1.853 millimole. From equation 2, 1 mole of sodium hydroxide is equal to 1 mole of hydrochloric acid. Therefore, the mole of sodium hydroxide is equal to mole of hydrochloric acid, which is 1.853 millimole. The third step is calculate the moles of sodium hydroxide reacted. The moles of sodium hydroxide reacted are calculated by subtracting the moles of sodium hydroxide unreacted, 1.853 millimole, from the initial moles of sodium hydroxide, 25 millimole, resulting in 23.147 millimole. From equation 1, 1 mole of ASA is equal to 2 mole of sodium hydroxide. Therefore, the mole of ASA is equal to 11.5735 millimole. Next, we calculate the mass of ASA. The mass of ASA is calculated by multiplying the moles of ASA, 11.5735 millimole, by its molar mass, 180.158 milligram per millimole, resulting in 2.0851 gram of ASA. And the last step is we calculate the percentage by weight of ASA. The percentage by weight of ASA is calculated by dividing the mass of ASA, 2.0851 gram, by the total mass of the sample, 3.8542 gram, and multiply by 100%, resulting in 54.10% ASA.
Next is about precaution. When conducting the analysis of acetyl salicylic acid ASA in aspirin, it is essential to follow certain precautions to ensure accurate and reliable result. Here are some key precautions to consider. The first one is about safety gear. We must always wear appropriate personal protective equipment such as gloves and safety goggles when handling chemicals. This will help us avoid direct contact with ASA and other chemicals to prevent skin irritation or allergic reactions. The second precaution to be considered is skill in handling equipment. As we know, in this analysis, we use many equipment. Therefore, we must develop proficiency in handling laboratory equipment such as burettes, pipettes, and balance to ensure accurate measurements and analysis. For example, we could ensure that the eyes are perpendicular to the meniscus when reading volume in glassware to minimize parallax errors. By adhering to these safety precautions, you can ensure the well-being of individuals involved in the analysis process and maintaining a safe laboratory environment. Thus, you can enhance the accuracy and reliability of the analysis of acetyl salicylic acid in aspirin while maintaining proper technique and quality control measures in the laboratory. In conclusion, this analysis successfully determined the amount of acetyl salicylic acid ASA present in a sample of aspirin using volumetric analysis. The process involved a titration reaction between the aspirin sample and a 0.1 molar of hydrochloric acid HCl solution. By carefully monitoring the color change of the indicated phenolphthalein, the endpoint of the titration was determined, allowing for the calculation of the ASA content. The result indicate that the aspirin sample contained 54.10% weight per weight of ASA, confirming its potency and effectiveness. This analysis demonstrates the accuracy and reliability of volumetric analysis as a technique for determining the concentration of a substance in a solution. It highlights the importance of this method in pharmaceutical quality control and research, ensuring the quality and effectiveness of medications.